This is an essay in the series After the Walls Come Down, Building New Institutions from the Remains of a Broken World by William Young.
The BBC broadcaster Guy Evans says that climate change is everything change because climate is the fabric on which we weave our lives. It determines where human habitation is viable, how we live, the timing of seasons, what food can be grown, where rain falls, how hot it is, the routing of ocean currents, and the severity of storms. Vince calls the climate crisis the most complex problem humans have ever faced. Elizabeth Kolbert is one of the first writers for a major publication, The New Yorker, to write articles about the climate crisis. She says that to bring the climate crisis under control, the fossil fuel industry will essentially have to be dismantled and millions of leaky and abandoned wells sealed. Concrete production will have to be re-engineered. The same goes for the plastic and chemical industries. Currently, ammonia, a critical component of fertilizer, is produced from natural gas, so the fertilizer industry will have to be refashioned. Practically all commercial and residential boilers and water heaters that now run on oil or gas will have to be replaced, as will all gas stoves, dryers, and industrial kilns. The airline and shipping industries will have to be revamped, and the way food is produced and delivered will need to change significantly. Caroline Lucas, a former member of the United Kingdom's House of Commons, says that climate breakdown is inseparable from politics. The melting ice caps, the scorching heat waves, and the staggering declines in animal and insect populations are the direct result of failures by people in power. Lucas and others believe we cannot live sustainably and meaningfully address climate breakdown within the current political and economic systems. How do you even begin to address a problem that is so enormous and multifaceted? And how do you inspire the public to take action and not lapse into despair when there are no good climate scenarios for the future? Based on current scientific knowledge, there are only bad scenarios, worse scenarios, and scenarios you don't want to think about. Americans and other people in developed countries should take every action to avoid the worst scenarios and the really horrendous ones. Generalist thinkers who can view the political, economic, and environmental factors will need to develop solutions that address the multiple causes of the crisis. An important first step will be to try to convince a majority of the American people that climate breakdown is happening and needs to be addressed immediately. This will be very difficult in a country where so many powerful interest groups, politicians, and the climate-denying MAGA president are doing everything they can to prevent action from being taken. Most Americans can be divided into four main groups about climate breakdown. First are people who neither know nor care about the crisis. They are more likely to be able to tell you all the people on television shows or sports teams than to know actions they can take to reduce carbon emissions. This group is very large. The second group contains people who think they are environmentally responsible but are not living in a sustainable manner. Their commitment does not go much beyond putting plastic bottles into a recycling bin or driving a hybrid or electric car. The third group includes people who believe climate breakdown is a hoax and/or do not want any political or economic action to be taken to address the crisis. Many of them voted for the climate-denying MAGA president. The fourth group, which is the smallest, consists of people who want to understand climate issues, are acting to reduce the emissions of their activities, and encouraging others to do the same. The majority of Americans seem to believe that the crisis does not exist or that some technological fix will be found to mitigate the damage. They feel no sense of urgency to act. There also is a large group who might want to act, but they do not know what to do. Not much climate progress will be made unless the people in the fourth group are able to convince the people in the first two groups about the seriousness of the crisis. Even the climate deniers in the third group possibly could undergo a conversion if catastrophic events begin to affect themselves or their families, but this is not likely. Many will probably look for people to blame rather than looking into a mirror. The fossil fuel industry commonly makes the argument that we need to maintain the status quo to keep the lights on. Anyone who lives in a home that has had a power outage realizes how dependent modern life has become on electricity. Solving the climate crisis will entail finding ways to keep the lights on without frying life on the planet. Many ways that Americans and other people in developed countries currently live are not sustainable and will need to change. Even though some of the world's most important climate research has been done in the United States, the government has resisted taking significant actions to address climate breakdown. In 1992, the United Nations sponsored an Earth Summit in Rio de Janeiro to discuss development issues. The delegates to the conference drafted a framework for developing a treaty to address climate breakdown. George H.W. Bush, who was the president at the time, responded to the framework by saying, quote, "The American lifestyle is non-negotiable," unquote. The unsustainable American lifestyle has remained non-negotiable ever since. In 1997, nations of the world convened in Kyoto, Japan to extend the work of the Rio Conference. The participants developed the Kyoto Protocol, whose goal was to reduce greenhouse gas concentrations in the atmosphere to a level that would prevent dangerous interference with the climate. The protocol acknowledged that individual countries have different capabilities to combat climate change, owing to their different levels of economic development. It placed the obligation to reduce emissions on developed countries, which historically had been most responsible for the excess levels of greenhouse gases in the atmosphere. The United States never ratified the Kyoto Protocol. Reiterating the non-negotiability of the American lifestyle, the Senate passed a resolution by a vote of 95 to nothing, saying that the country should not ratify any climate treaties that would mandate new commitments to limit or reduce greenhouse gas emissions if developing countries were not required to do the same, or if the treaty would do serious harm to the U.S. economy. Democrats and Republicans in the Senate concurred that a strong economy was much more important than a livable climate, a principle consistent with free market philosophy. The United Nations sponsors annual conferences at which the countries of the world gather to assess progress in addressing climate issues. The first such conference was held in 1995. At the 2015 conference in Paris, the attendees produced an international climate agreement which has the long-term goal of keeping the rise in the average global temperature to less than 2 degrees Celsius above pre-industrial levels, and preferably to 1.5 degrees, recognizing that the lower number would substantially reduce the effects of climate breakdown. At the time, scientists estimated that to stay below 1.5 degrees, worldwide emissions would need to be cut by roughly 50% by 2030. The Paris Agreement was hailed as an important breakthrough for addressing the climate crisis, except that it has not done much to actually slow climate breakdown. The United States, which historically has emitted more greenhouse gases than any other country, has twice signed the treaty, only to have the climate-denying MAGA president twice withdraw from it. Quite a few other nations agreed to cut their emissions to zero by 2040, 2050, or 2060, but many are now backtracking. Keeping the average global temperature to 1.5 degrees Celsius above pre-industrial levels is not going to happen. In 2024, the average world temperature for the year was already 1.55 degrees Celsius above pre-industrial levels. That was for only 1 year, and the temperature in the treaty is based on a 20 to 30-year average. In looking at the climate turmoil that is currently happening, stabilizing the global temperature at 1.5 degrees above pre-industrial levels will not produce a stable climate. It will keep what we have now for a very long time into the future. And global temperatures are not cooling. Keeping global temperatures to less than 2 degrees Celsius above pre-industrial levels now looks highly unlikely. By the end of the 21st century, the increase will likely be closer to 3 degrees than 2 degrees, in the you don't want to think about it range. Elizabeth Kolbert has been warning about the need to address climate breakdown for a long time. Field Notes from a Catastrophe, published in 2006, is a collection of some of her early climate articles for The New Yorker. In it, she quotes the Princeton physicist Robert Socolow, who had been involved in a lot of issues which had both a lay opinion and a scientific opinion. He said that in most cases, the lay community was more alarmed and anxious. But with respect to climate, Socolow said experts who work with climate models every day and scientists who drill ice cores are more concerned than the public. They are going out of their way to say, quote, "Wake up, this is not a good thing to be doing," unquote. In 2022, Kolbert wrote a New Yorker article called Climate Change from A to Z. In it, she wrote that to say that amazing work is being done to combat climate change and that almost no progress has been made is not a contradiction. In 1992, the year of the Rio Summit, fossil fuels provided roughly 80% of the world's primary energy. 30 years later, fossil fuels still provided roughly 80% of the world's primary energy. In the interim, total global energy use increased by almost 2/3. A lot of the advances in renewable energy supplemented fossil fuel rather than replacing it. Kolbert said that despite dire warnings about the effects of fossil fuel use on the climate, people have emitted more carbon dioxide into the atmosphere since the Rio Summit than in all of the rest of human history. Gus Speth, a lawyer who co-founded the Natural Resources Defense Council and was the former chair of the Council on Environmental Quality during the Carter administration, wrote a book called They Knew: The U.S. Government's 50-Year Role in Causing the Climate Crisis. The book was adapted from a brief Speth wrote in support of 21 young people who sued the federal government for encouraging and permitting the combustion of fossil fuels. The plaintiffs said that by doing this, the government knowingly violated the young people's rights of life, liberty, and property, as well as violating the government's sovereign duty to protect public grounds. Speth's book documents how almost every administration, both Democrat and Republican, talked about the need to address the climate crisis while continuing to promote fossil fuels. Carter, Clinton, and Obama were not much different than Reagan and the two Bushes. The only exception was the climate-denying MAGA president, who has strongly promoted the use of fossil fuels without pretending to care about climate breakdown. In 2020, a 3-judge panel on an appellate court ruled 2-1 against the 21 young people, with Judge Josephine Staten sharply dissenting. She wrote, quote, "The United States has reached a tipping point, crying out for a concerted response, yet it presses ahead toward calamity. It is as if an asteroid were barreling toward Earth and the government decided to shut down our only defenses. Seeking to quash this suit, the government bluntly insists that it has the absolute and unreviewable power to destroy the nation," unquote. Judge Staten ended her dissent by chastising the 2 judges in the majority. She wrote, quote, "Where is the hope in today's decision? The plaintiff's claims are based on science, specifically an impending point of no return. If the plaintiff's fears, backed by the government's own studies, prove true, history will not judge us kindly. When the seas envelop our coastal cities, fires and droughts haunt our interiors, and storms ravage everything between, those remaining will ask, why did so many do so little?" Unquote. Scientists are partly to blame for the perceived lack of urgency in addressing climate breakdown. Simon Sharp, a senior fellow at the World Resources Institute, says that climate scientists need to think more like risk managers. His book, 5 Times Faster, makes the point that if the world is to meet climate goals, the world economy will need to be decarbonized 5 times faster in the 2020s than it has in the previous 2 decades. Sharp compares humanity to a frog in a pot of water heating on a stove. A science advisor might tell the frog that in 5 minutes the water will be 2 degrees warmer, plus or minus a degree. The frog then says she did not want a prediction, but rather a risk assessment about what is the worst that can happen. The scientist says that in the worst case, the frog will boil to death. The frog asks, how likely is that? And the scientist says that in 5 minutes, it definitely will not happen. In 10 minutes, it's 50-50, and in 20 minutes, it's 100%. Sharp says that the vast majority of climate reports give predictions rather than risk assessments. He says that instead, scientists should first say what is the worst case and then how likely it is. Scientists prefer certainty. If a catastrophic event has an 80% likelihood of occurring, scientists might be reluctant to release the findings. If the event does not happen, they might be called chicken littles and lose credibility. In the field of risk management, the precautionary principle says that if there are threats of serious and irreversible damage, lack of full scientific certainty should not be a reason to postpone action. Responsible risk managers who see an event with an 80% likelihood will take action to prepare for it. The climate is so complex with so many variables that certainty is usually not possible. Climate science deniers use the uncertainty to say that scientists do not know what they are talking about. The responsible scientific community is in total agreement that climate breakdown is happening. The uncertainty about climate breakdown relates to the speed, timing, and degree it is occurring. Before the COVID-19 pandemic, Anthony Fauci, Bill Gates, and others predicted the world would see a serious pandemic in the near future, but none knew exactly what the disease would be, when it would occur, or its severity. It is important to understand basic concepts about climate breakdown. Climate involves patterns of temperature, humidity, atmospheric pressure, wind, and precipitation over an extended period. Weather describes the current state of these variables. Climate is long-term and weather is short-term. The Earth's atmosphere consists of about 78% nitrogen, 21% oxygen, and 1% argon. These 3 gases comprise 99.95% of the atmosphere. Nitrogen and oxygen are mostly transparent, so sunlight passes through them and warms the surface of the Earth. As the Earth warms, it reflects heat back into space in the form of infrared radiation, which these gases do not absorb. The atmosphere has trace amounts of other gases, including carbon dioxide, methane, water vapor, ozone, and others. Only a tiny amount of the Earth's atmosphere is carbon dioxide, about 1 out of every 2,340 molecules of air. These trace amounts make a huge difference. They and the other gases absorb and trap some of the infrared radiation and send it back toward the Earth's surface in a manner analogous to heat coming through the roof and windows of a greenhouse and keeping the plants inside warm. This is the basis for the terms greenhouse effect and greenhouse gas. Greenhouse gas emissions are not the same as greenhouse gas concentrations. Emissions are greenhouse gases pumped into the atmosphere, usually measured in billions of tons. Concentrations are what stays in the atmosphere. Emissions and concentrations have risen together. If the countries of the world could magically stop all greenhouse gas emissions immediately, the change would not be felt for a very long time because of the concentrations already in the atmosphere. Methane is estimated to be 28 to 80 times more potent a greenhouse gas than carbon dioxide, but it stays in the atmosphere less time before breaking down, about a dozen years versus hundreds to thousands of years for carbon dioxide. For planning purposes, once carbon dioxide enters the atmosphere, it stays pretty much forever. Before the Industrial Revolution began more than 200 years ago, the concentration of carbon dioxide in the atmosphere was about 280 parts per million. This is the baseline level scientists use to determine how much humans have altered the atmosphere. By 1970, the average level had risen to 325, and by 1990, it was 354. 350 is considered an important threshold based on the work of James Hansen, the director of NASA's Goddard Institute for Space Studies from 1981 to 2013. In 1988, Hansen's testimony before the Senate was international news when he said the Earth was warmer than at any time in recent history. He said this warming of the planet could be attributed with 99% certainty to human activities, primarily burning fossil fuels and changes in land use. He added that the carbon in the atmosphere was making extreme weather events, such as heat waves, storms, and droughts, more frequent and intense. A 2008 paper, which Hansen co-authored, said that if humanity wishes to preserve the planet in a condition similar to that in which civilization developed and to which life on Earth is adapted, atmospheric carbon dioxide must be reduced to at most 350 parts per million, but likely less than that. Returning to a level of 350 is not going to happen at any time that matters to people now alive, or to their children, or grandchildren, or great-grandchildren, or great-great-grandchildren. In 2025, the atmospheric carbon dioxide is in the high 420s and rising. The carbon dioxide level is much more likely to increase to 550 than fall back to 350. Almost all the world's oil and gas fields are found in only 27 key regions in the world. They underpin the fossil fuel economy, which is worth trillions of dollars a year. People die in wars that countries fight over fossil fuels. The major petrostates wield enormous power in global politics because of their large supplies of fossil fuels. Governments all over the world heavily subsidize the fossil fuel industry, which means the users of fossil fuel do not pay the full price for it. To slow or stop climate breakdown, the major petrostates will need to stop producing fossil fuels, and that is not likely to happen. These petrostates include the United States, yes, the U.S., Russia, Saudi Arabia, Iran, Venezuela, and others. An ecological threshold is the point at which a relatively small change or disturbance can cause a large, irreversible change. A closely related term is tipping point, which is like the straw that broke the camel's back. For many tipping points, everything looks fine until suddenly it does not. Once a tipping point is passed, it can cause self-perpetuating feedback loops, so the change continues even if whatever caused it stops or drops below the tipping point. It might take decades, centuries, or millennia before a feedback loop stops and the system finds a new equilibrium. The fact that crossing certain tipping points does not necessarily cause feedback loops to begin immediately is one of the great challenges climate scientists face when making forecasts. One feedback loop involves Arctic and Antarctic ice. Albedo is a term that comes from the Latin word for whiteness. It measures the reflection of solar radiation. White surfaces reflect light and heat, while dark surfaces absorb light and heat. An ideal white surface reflects all light shining on it and has an albedo of 1. An ideal black surface absorbs all light and has an albedo of 0. The albedo of the entire Earth is 0.3, which means a little less than a third of the sunlight striking it is reflected back into the atmosphere. Anything that changes the Earth's albedo changes how much heat energy the planet absorbs, with potentially dramatic consequences. Polar ice covered with snow is bright white and has an albedo of around 0.8. It reflects about 80% of the sunlight, the highest albedo of any area on the Earth's surface. The ocean has an albedo less than 0.1. The albedo of ocean water is as low as any area on the Earth's surface. When snow and ice melt and become ocean water, the best reflector is replaced by the best absorber. The more open water that is exposed without ice, the more solar energy heats the ocean. This melts more ice, which creates more dark surface, which absorbs more heat, which melts more ice, and so on. Once this feedback loop starts, it is difficult to stop. Permafrost is a mixture of soil, rocks, ice, sediment, and organic matter that stays frozen throughout the year. It is in the top few meters of Arctic land and holds an enormous amount of carbon dioxide and methane. Rising temperatures can cause the storage process to run in reverse. In parts of the Arctic, this process is already underway. Organic material that has been frozen for millennia starts to thaw, giving off carbon dioxide and/or methane. As permafrost melts and stops being perma or frost, carbon is released into the atmosphere, which heats the planet and causes more permafrost to melt, and so on. Wildfires are increasing in frequency and intensity. The hotter climate leads to less rain and more dry, flammable material on the ground. This increases the likelihood and intensity of fires, which release an enormous amount of carbon into the air, which warms the climate and creates more dry material on the ground, which leads to more fires, and so on. In hot weather, people use more air conditioning. If the air conditioners are not powered by renewable energy, a greater amount of greenhouse gases goes into the atmosphere, making the weather hotter and causing people to use more air conditioning, and so on. The most commonly used refrigerants in air conditioners are hydrofluorocarbons, which are greenhouse gases that can be thousands of times more potent than carbon dioxide if they escape into the atmosphere, which becomes more likely when more air conditioners are used and ultimately disposed of. Many of these feedback loops are based on elementary physics. No matter how much the MAGA regime has turned its back on science, the physics will not be affected. The laws of physics, like the American lifestyle, are non-negotiable, and physics can cause much more serious consequences. The word fossil comes from the Latin fodere, which means to dig. A fossil is something that is dug up. Fossil fuels are essentially buried sunlight. The original source of the energy in fossil fuels is photosynthesis from plants, as well as animals who ate the plants. The dead plants and animals are the fossils in fossil fuels. 90% of carbon dioxide emissions comes from burning fossil fuels, and 20 fossil fuel companies have been responsible for more than a third of all carbon dioxide emissions since 1965. Bill McKibben, one of the leading figures in the movement to try to stop climate breakdown, has pointed out that fossil fuel is miraculous stuff. It is like living on a planet pulsing with energy and using many suns. A single barrel of oil, 42 gallons, can do about the same amount of work as someone working 25,000 hours. Using fossil fuel can provide each person with the equivalent of dozens of servants. People can extend light long past sunset. People can control the heat and cold of indoor environments. People can easily move themselves and their belongings long distances. McKibben adds that it is too bad that using fossil fuel is also destroying life on the planet. The story of fossil fuels reminds me of the Greek myth about the Titan Prometheus. He was a favorite of Zeus on Mount Olympus, and at Zeus's suggestion, he used clay to model the first men. Women were created later. Zeus stipulated that men should never have fire lest they rise up and challenge the gods. After Prometheus saw what he had created, he thought men lacked zest and needed fire. He disobeyed Zeus and stole fire from the gods to give to men. Zeus punished Prometheus by chaining him to a rock and sending an eagle to peck at his liver every day. But humans kept fire, and they have been burning things ever since, including enormous quantities of fossil fuels. Many causes of climate breakdown stem from humans trying to mimic nature without fully understanding the implications. Over many millions of years, creatures and processes have evolved into their current states. Humans have tried to take shortcuts to produce the same results, often with disastrous consequences. They have attempted the shortcut of burning the stored sunlight in fossil fuels without understanding the implications of sending the previously sequestered carbon into the atmosphere and oceans. Some estimates say that humans are using 1 million years of fossilized sunlight each year by burning fossil fuels. This ancient sunlight powers the modern world by releasing a level of carbon dioxide similar to the level responsible for the difference between an ice age and when the Earth was like a tropical greenhouse. One often sees stories about projects to produce power sources to replace fossil fuels. Simply because something can be done once does not mean it can be scaled up to make a significant difference to address problems in a world with more than 8 billion people. Some limitations involve cost, others involve the availability of materials. Such schemes receive a lot of publicity because many people hope for solutions to climate breakdown that will result in people not having to alter their existing lifestyles. Tree planting is one of the most commonly promoted ways to remove carbon dioxide from the atmosphere. Forests absorb more carbon dioxide than meadows or grasslands, which in turn absorb more carbon dioxide than lawns. Some people propose planting 1 trillion trees. Currently, the world has an estimated 3 trillion trees. To plant an additional trillion would require vast amounts of land, and it is not clear where these trees could be planted. Grasslands are among the most threatened habitats in the world, so trees should not be planted there. Land is not likely to be taken from agriculture because the world needs to feed more than 8 billion people. Also, you cannot plant a forest. A forest is an ecosystem, and one will not result simply by planting a lot of trees. Not all trees are equal in their ability to absorb carbon. A seedling might take 20 or 30 years or more before it absorbs as much carbon as a mature tree. A lot of fanfare surrounds tree planting ceremonies, but few people return to see how many of the trees are still alive 1, 2, or 5 years later. People sometimes plant the wrong kinds of trees, and even with the correct kinds, keeping planted seedlings alive is not easy. Young trees are under threat from temperature, lack of water, too much water, and browsing by animals, such as deer. Trees can prevent erosion, reduce the level of carbon dioxide in the atmosphere, and provide much needed shade. Tree planting also can have a significant positive impact in large cities, where in combination with green roofs on buildings, they can absorb some of the heat created by the urban heat island effect. However, they can never be planted in a great enough number to have a significant impact in addressing climate breakdown. A much greater focus should be put on preventing the destruction of existing forests, which are being lost to logging, fires, pest infestations, and stresses caused by the heating climate. Carrying capacity is the number of people, other living organisms, and/or crops a region can support without causing environmental degradation. The Earth's carrying capacity, based on current conditions, is thought to be less than 10 billion people. Almost all food currently comes directly or indirectly from plants that photosynthesize, and photosynthesis requires water for plants to grow. In hotter weather, water evaporates faster from soil and leaves. Heat-stressed plants and animals need more water. Some agricultural areas are already experiencing conditions with a lot more heat and/or a lot less water. Either factor can cause food production to decline and reduce the Earth's carrying capacity for humans. In biology, every species has a critical thermal maximum and a critical thermal minimum. These are maximum and minimum temperatures at which an organism ceases to function. Between the two extremes is an organism's comfort zone. Different organisms have different comfort zones. Reptiles cannot internally regulate their body temperature, so their comfort zone will be different from mammals, who can regulate their body temperature. Mammals in cold climates have different comfort zones than mammals in the tropics. Plants have comfort zones which vary by species. Wheat has a different comfort zone than oranges. Extended periods outside the comfort zone, such as a prolonged heat wave in a wheat growing area or an unexpected freeze in an orange grove, can damage or destroy a crop. People began to farm around the time the last ice age ended, about 12,000 years ago. Since then, farmers have preferred areas with an average temperature of about 55 degrees Fahrenheit, or 13 degrees Celsius, which tends to create the best conditions for growing crops and raising livestock. A lot of farming in the world takes place in areas around this average temperature. As the planet continues to heat, areas with this average temperature are moving closer to the two poles. Unfortunately, farmers cannot move their fields to stay in an amenable temperature zone. The wet bulb temperature is a measure of the effects of heat combined with humidity. It is an expanded version of the heat index in weather forecasts. At 100% humidity, the wet bulb temperature is equal to the air temperature. At lower humidity, the air temperature is higher than the wet bulb temperature. At high levels of humidity, sweating and breezes are less effective for cooling a body. For humans, a wet bulb temperature of about 95 degrees Fahrenheit or higher, 35 degrees Celsius, is considered lethal. Humans are not able to dissipate the heat they generate indefinitely, and even fit people can die from heat stroke if exposed to such heat and humidity for 6 hours or more. Heat is now one of the biggest environmental threats to human health. Around 1% of all deaths in the world can be attributed to heat, putting it on a par with deaths from malaria. Hot conditions can affect the ability of people to work in agricultural fields. Smallholders are people who farm less than 5 acres of land, and they produce about a third of the world's food. As average temperatures increase, a high proportion of these small farmers, who are concentrated in places with hot climates, might be unable to work outside for important portions of the year. According to an article in the British medical journal The Lancet, harmful temperatures are similar for humans, cattle, pigs, poultry, and agricultural crops. Short exposures to temperatures above 95 degrees Fahrenheit with high humidity, or above 104 degrees Fahrenheit, 40 degrees Celsius, with low humidity, can be lethal. Already, more than 350 major cities around the world have an average maximum summer temperature above 95 degrees Fahrenheit. As the climate heats, many more cities are expected to join this group. Regardless of the average temperature in an area, a short period of extreme weather can do damage. It is not only life forms that are affected. Extremely hot weather is already affecting infrastructure, causing roads to buckle, railroad tracks to weaken, and airport tarmac to soften. Air conditioning is partly to blame for the lack of concern about climate breakdown. People who do not have to work in the searing heat are not as aware of how hot the weather is getting. For a lot of people in developed countries, high temperatures are felt mostly as they move from one air-conditioned environment to another. When the planet's average temperature goes from 1.5 degrees Celsius above levels before the Industrial Revolution to 2 degrees Celsius, the change will be gradual, and people are not likely to notice until it is too late. This is why the analogy with the frog in the pot of heating water is so apt. Addressing the climate crisis reminds me of what Carl Sagan said when asked how to make an apple pie from scratch. He answered that, quote, "You must first invent the universe," unquote. Sometimes it seems that ending fossil fuel use and stopping climate breakdown is a task almost as large. Nothing will stop it, but in light of the dire threat it poses, developing viable alternatives to the fossil fuel economy should be a top priority of every developed country in the world. The longer meaningful action is delayed, the worse the situation will become.